Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 10, Half-Angle Identities. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we derived and used many identities. Here's a quick rundown. Double angle identities. There were 5 of them. Product to sum identities. There were 4 of them. Sum to product identities. There were also 4 of them. And most recently, power reducing identities, of which there were 2. In this video, we derive one more category of identities, half-angle identities. The first 2 half-angle identities are derived from power-reducing identities, which were derived from double-angle identities, which were derived from sum identities. It's just a constant evolution of identities. But let's start with cosine squared of x equals 1/2 times 1 plus cosine of 2x, which again was this power-reducing identity. So why do we start with that? Well, because one of the angles, x, is half another angle, 2x. So we can do a substitution to set up a half-angle expression. We're going to replace each x in this identity with x over 2. So let's remove the x's where they currently are, replace them with empty parentheses just for the time being, and now fill in those parentheses with x over 2. Now we have a simplification over here where 2 times x over 2, the 2's cancel. And we have cosine squared of x over 2 equals 1/2 times 1 plus cosine x. Remember, we're trying to create a half-angle identity, so we want an identity that starts with cosine of x over 2. We can achieve that by taking the square root of both sides. Remember, the plus minus. When you square root both sides of an equation, bring in a plus minus. We're going to clean this up a little bit by putting the 1 plus cosine x over the 2. Now, as far as the sign, the plus or minus, that's based on the quadrant of the angle x over 2. So whatever angle is here, if cosine is positive, we choose the plus. If cosine is negative, we choose the minus. And again, cleaning up the radicand, we could put the 1 plus cosine x over the 2. And this is our first half-angle identity. Again, notice we rewrote the radicand as a single fraction, removing the need for parentheses. Parentheses here. No parentheses. It's a little bit cleaner in my opinion. Now, using a similar approach, we can take the power-reducing identity sine squared x equals 1/2 times 1 minus cosine 2x, do the exact same song and dance, and end up with the half-angle identity sine of x over 2 equals plus or minus the square root of 1 minus cosine x over 2. So far we have these 2 identities, where the sign, S-I-G-N, depends on the trig function and the quadrant of x over 2. Now we also have one for tangent. Actually, we have 3 for tangent. So let's derive the half-angle identities, plural, for tangent. Using a quotient identity, we immediately have the following. Tangent of x over 2 equals sine of x over 2 over cosine of x over 2. But we can put the half-angle identities on top of each other, and through a little bit of algebraic manipulation, we can merge these into one fraction. The 2's cancel, and we get plus or minus the square root of 1 minus cosine x over 1 plus cosine x. Now, this is a perfectly good half-angle identity, but there are 2 other versions of the half-angle tangent identity that I think are a little bit better. So what are they, and how do we get them? Well, to derive each, we're going to multiply by conjugates. And just a reminder, when you have an addition or a subtraction problem, its conjugate is the corresponding subtraction or addition problem. For example, the conjugate of 1 plus cosine of x is 1 minus cosine of x. And there's an advantage to multiplying conjugates. We're going to multiply both sides of this fraction by 1 minus cosine x, like that. Now, what's the advantage of multiplying by conjugates? Well, without getting into all the details, when you multiply a pair of conjugates, you get a difference of squares. And that should be an algebra move that you're somewhat familiar with. To demonstrate what I mean quickly, if I can get this pen to work, When you multiply a plus b times a minus b, if you were to FOIL it out, you get a squared minus b squared. So multiplying a pair of conjugates always results in a difference of squares. Is that advantageous here? Of course it is. What's going on? Of course it's advantageous here. Because watch what happens. When we multiply both sides by the conjugate, the numerator is just 1 minus cosine x all squared, but the denominator will give us 1 minus cosine squared. And so now it looks like this. Well, 1 minus cosine squared is just sine squared by a Pythagorean identity, so the denominator becomes sine squared. And now notice that both sides of this fraction are squares under a square root. So the square root cancels the squares. Square root cancels the squares. We still have the plus minus, but if you analyze the signs of the trig functions quadrant by quadrant, you'll discover that tangent of x over 2 and 1 minus cosine x over sine x always have the same sign. For example, if you're in quadrant 2 between pi and 3 pi over 2, then half of you is between pi over 2 and 3 pi over 4. That would put x over 2 in quadrant 2. Well, in quadrant 2, tangent is negative, and in quadrant 3, both cosine and sine are negative, so the top becomes 1 minus a negative, which is positive, over a negative, which is negative. So these both end up being negative. Similar arguments work for other quadrants. As a consequence of these observations, we can lose the plus minus and get tangent of x over 2 equals 1 minus cosine x over sine x. We don't have to decide on a plus minus. Now, if we go back to this tangent half angle formula, and this time multiply by the conjugate of the numerator, in other words, multiply both sides by 1 plus cosine x, we kind of get the same song and dance, except the results end up like this. Tangent of x over 2 equals sine of x over 1 plus cosine of x. So, here are all the half angle identities. Cosine of x over 2 equals plus minus the square root of 1 plus cosine x over 2. Sine of x over 2 equals plus minus the square root of 1 minus cosine x over 2. And tangent of x over 2 has three variations. Plus minus square root of 1 minus cosine x over 1 plus cosine x, or just 1 minus cosine x over sine x, or sine x over 1 plus cosine x. In all cases where there's a plus minus, the sign of the square root depends upon the trig function and the quadrant of the angle x over 2. There is no now you try this for this video. There will be one in future videos. Besides, this video has already gone on pretty long.